This is from Fall 2011 Math 227 Test 3. Number 7. Two methods of chemical reduction are being studied in 7 different locations. Both methods are applied to all locations and the total chemical reduction was recorded. Now we have method 1 and method 2. Now at 5% significance level, do these data indicate any difference in the reduction of chemical between two methods? Notice that you apply both methods to all locations such that then we have paired data. Okay, we have paired data. Now what I will do next is to find the difference between those two. Let me do it down here. Maybe here I sneak it in. Okay, let me use red color. I will find the difference between these two methods. Okay, this will be, you can because we don't know which one is first, which one is later. Okay, so you can subtract in any direction. Like right now I will subtract in the direction top minus bottom, so I will get negative 0.1, negative 2.8, negative 0.2, the 1.6 here, and this is negative 1.0, 0.1, negative 0.3. Those are the differences. Okay, now then from there I will compute the d bar, which is quote unquote the sample mean of the differences. Okay, which is sigma of d over the number of data, which is 7. Now if I add the data I have there, now if you subtract the other way around, which is okay, you will get the opposite of these here. Okay, negative 0.1 minus 2.8 minus 0.2 plus 1.6 minus 1 plus 0.1 minus 0.3. I get negative 2.7, which if I divide by 7, I will get negative 0.38571. Okay, and then I will compute the variance of the differences. Okay, and sigma d squared minus sigma d quantity squared over n times n minus 1. Okay, now the n we know is 7. This is 7 here, and down here 7 times 6. Okay, and then let me leave it blank here, minus the sigma d is negative 2.7, which I will square later on. Now let's see the square of those. 0.1 squared plus 2.8 squared plus 0.2 squared plus 1.6 squared plus 1 squared plus 0.1 squared plus 0.3 squared. Now you may wonder why I don't use negative when I square it, because negative number being squared is positive anyway. Okay, so I don't need to do that. That's 11.55. Then I get times 7 minus 2.7 squared. That is 73.56 over 42. This is equals to 1.75143. Therefore, the sample standard deviation of the differences will be the square root of that number. I get 1.32342. Okay, now the setup is good enough. Okay, the significance level is 5% or 0.05, right? And then now let's start. Step 1, the claim. Now it is in question though. It doesn't really make any kind of claim. So you choose the claim yourself. Okay, because any claim you make will come up to two sides of the coin anyway. It's either the claim or the opposite of the claim. So in the end, you will come up with the same conclusion. Okay, but you need to make a claim right now. Let's say you say that this data does not. You don't have to use does not. You can say does not indicate any difference in the reduction of chemical between two methods. Okay, step 2, the hypothesis. Null hypothesis, alternate hypothesis. You see, if doesn't indicate any difference means the mean of the difference is 0, right? The mean of the difference is 0. Now, if it does indicate any difference, some difference, then the mean of the difference will not be equal to 0. Okay, in other words, yes, we have some difference from our sample, right? The average sample mean of the difference, the average sample difference is not 0, right? But is this difference is simple because of the randomness, or really because of the differences that built in systematic? Okay, then that's why we come up with that test statistic. Anytime you have paired or matched data like that, you basically treat your D as the regular X, and this will be X bar, and this will be the S squared, the sample variance and sample standard deviation, like that. Now from there, then we realize that here I will use the T distribution. Okay, the test statistic will be in T's, which is negative 0.38571. That's the sample differences, sample mean for the differences, minus the expected sample mean of the population mean of differences over the standard deviation over the square root of the sample size. Okay, now let me see, that will be negative 0.38571 divided by that standard deviation, okay, then multiplied by the square root of 7. That will be negative 0.77111. Now, step 4, the critical value. The TC. Now we do a two-tailed test because we want to see how much differences is made, right? It's 5%, so this is 2.5. The area of the two-tail will be 2.5% each, or the area of the total is 5%. It's 5%. It will be 2.365 ml. Okay, the area in two tails. The degree of freedom is, oh, hold on, the degree of freedom is 6. The degree of freedom is 6 is actually 2.447. I need to write it down. Degree of freedom is 6. So I get 2.447. Now clearly, we can tell already because this is too small, you know, not too far enough from 0. So this is negative 0.77111, while the T critical will be the plus minus, right? This one is negative 2.447 and this one is 2.447. Okay, here we see that our informal conclusion is informal conclusion, we say that accept null hypothesis. In other words, if we do the formal conclusion, we say at 5% significance level, the sample data fail to reject the claim that this I think I should say data does not indicate any difference in the reduction of chemical between two methods. Okay, now this is from fall 2011 Math 227 test 3 number 7. That's a long one. Yeah. This is the second part. The first part, the preparation part, is here.